So I wanted to do a more thorough overview of my matrix module to clear up some of the confusion that people have been having with this module. So just a quick overview, we have the controller module, there's a matrix device module, and then there's a control routing module which ties into Crosspoint so you can adjust where the control signals go for all your serial strings that send the power on and off commands to displays and stuff like that, depending on the physical wiring of like a DM switch or something, or an NVX setup. And so the controller module has essentially a lot of global actions. So anything that gets triggered in terms of presets, clear routing, snapshots, virtual input for all outputs, and so on, including the auto routing, just forwards all these actions towards the device modules. So all the device modules that are in the program will see messages associated with this. And for a quick demonstration, I had mocked up this kind of a setup within the Simple Windows program. So we have a 2x2 matrix, which I can control here individually. There's a 3x3 matrix and a 2x1, which loops back into here. And then I have a visual representation of the current state of each of the matrices, represented by an individual X panel per each. So in this case we have the 2x2, here's the 3x3 matrix, and the 2x1 is this far right X panel over here. So I've already loaded the program automatically loads the config, so you can see the configurations loaded and modules initialized has went green. These ones won't apply until those outputs get pulsed. So for instance, if we were to type in some invalid routing keys, you can see it turns red for a split second there and then goes back. And nothing happened on the switches. But if we put in a valid routing key, which is denoted by the identifier, an exclamation point, and the video or audio component or USB component or whatever combination is defined, and those are specified in the help files. And then colon, and the output routing key must contain output there, and the input routing key must contain input, and then both have the 3-digit input or output number associated with it. So for in this case, the input routing key, this denotes this particular node highlighted in pink, and the output node is denoted by D1, also highlighted in pink. So we can see the output routing key is 3x3 matrix, video component output 1, which is what D1 represents, and the 2x2 matrix, video input 1 is representative of the A1 node here. So when we did the auto route, it did that routing, so it sent A1 all the way to through F1 and then back from C3 to D1. So you can see the D1 node there has its source name of A1. And you'll also notice that the input names changed. So this used to say B1, but because the output from B1 has the A1 source routed through it, it sends that source name to represent the input name for what used to be C1. So now you can see the input name is A1 there, and this is essentially how we translate the source routing names all the way through to your destination through multiple matrix devices. And that can be enabled or disabled by this dynamic name property. So you can see there's some values that are false here. And if we scroll down, I've got C1 through C3 dynamic name is enabled, and the reason for that is because if we look at our matrix diagram here, these are not inputs on this matrix that are fed directly by a source. They're fed by their matrix outputs. So the actual source that gets fed through these inputs can change. And so this is a nice way to represent the actual source that is fed to that input. And then on the corresponding symbol Windows side, the way that is all done, since we have output source routing text as feedback, we can simply go, so if we look at our diagram, the output of B1, we want to send that source text to the input of the 3x3 matrix at input 1. So I'll open up the 2x2 matrix, which you can see in the comments here, and the 3x3 matrix, which you can see in the comment here. So these two symbols represent these two devices. And if I can keep this open and show you what's going on in the program, I can kind of clarify how this works. So if we scroll down, I need to expand this, you can see the virtual output source names we define for output 1 and 2. And if we follow this signal, for example, this goes to the 3x3 matrix at virtual input name for the slot 1. And you can see that here. So basically, whenever this source name changes, it'll change the input name of this 3x3 matrix to reflect that source that was routed from this output to the corresponding input on this device. So we did that for B1 to the C1 input and B2 to the C2 input, or otherwise output 1 from the 2x2 matrix to input 1 on the 3x3 matrix, and output 2 on the 2x2 matrix to input 2 on the 3x3 matrix. This one actually comes from a different switch, the 2x1 matrix, so it's a similar setup. It goes from output 1 on the 2x1, and that's where we feed this source routing feedback to input 3 so that this can be updated. So essentially this A1 text will follow through all the way so that we can denote the fact that A1 has been routed through here, even though it's gone through multiple switches. Otherwise, if we didn't have this dynamic name functionality, the best we could do is we could say that C3 is routed to D1, which doesn't really indicate much. So back here is where we define the connections between each of the matrix devices, and then all the other nodes that you don't see defined throughout this entire config file, they all follow the same convention, being the identifier, which is defined, its user-defined value, the video or audio component, colon, and the input, and then 3-digit input or output number. Where you can see this video or audio or USB component defined is all dependent on what you've defined down here for the actual subclass identifier. So you can see all the appropriate values here. The only different one being video plus audio. If you wanted this symbol to represent both audio and video at the same time, otherwise you could duplicate the symbol out and you could represent video and audio components separately and adjust them accordingly. So that's enough for the config file for now. I'll go through some of the test panel to demonstrate how this module works. So now that we have our routing, which was enacted by this auto routing capability, what we can do is we can save a snapshot globally, or we can save them individually. So you can see here we can save the snapshot state for the 2x2 matrix in slot 1. And then if we were to clear the routing, you can actually recall that on this one device. So the source routing changed on the first matrix, but it didn't change on any of the others. The only thing that changed was the input name because of our dynamic text thing that I was explaining earlier. But if we clear this again and we auto route everything, you can see on the 2x1 matrix, the 3x3, and the 2x2, we changed all the source routing. And if we save a snapshot in slot 1 globally, what will happen is the routing for the 2x2 and the 3x3 and the 2x1 matrix, that routing state gets saved to snapshot slot 1 across all 3 device symbols. So you can see that here. And the default name includes a timestamp, which is a dynamic variable. So you can see in the config file, we've got like a special notation here, and you can actually define how this timestamp looks based on this format specifier. And this format specifier is consistent with the way you would define a formatted datetime in C#. And then the cache files, if we were to save the in-memory snapshots to disk, you can define the file path at which these get cached. So if we go back here in our CP4 directory, FTP, I might have to reload this. You can see those cache files exist, and we can export our current snapshot routings to those files. And now that they're in those files, we can delete all the snapshot information, so you can see there's nothing across any of the slots on any of the devices. But we can import from this saved file on disk, all three of them for each of the devices, on a global level or a per device level as usual. So you can see here I can import just the one for the 2x2 matrix, or I can import everything. And now we have our data back in memory. And then I can delete it, and then if I deleted those, I can also export that. So now the information is changed, and if I import it after deleting all these, because I saved it with an empty information at slot 1 for the 3x3 matrix and the 2x1, it didn't import anything because that data was empty across these files. And so within the config file, what I also did, and this is the difference between snapshots and presets. Snapshots are defined at runtime based on the current state of each of the matrix device symbols in terms of their routing. And routing presets are not based at runtime. They are based on what you've defined for the routing capabilities within the configuration file. So I've got a preset named A for all three devices. You can see. And as per usual, we can recall A on a per device level. Let's just clear this so you can see. Oops. We can call it on a per device level, or we can recall it globally, which I'm going to have to clear everything so you can kind of see things change. And you can see it recalled the preset that was defined for A on each of the three matrix devices. And the other thing is that you can, so if you didn't like the name of the snapshot, which is defined by default from the value that you define in the config file, so you don't have to necessarily have the formatted dynamic variable for the date time in there. You can define this however you want. But even if a snapshot gets saved with a name, you can change this name at runtime. So if this was our presentation, and I programmed this so that when this changes and settles for 0.5 seconds, then it saves the name. So you can see here if we go snapshot slot 2 and then back to 1, our name persisted there. And the other thing is that this name that gets grabbed from the config file only applies to snapshots that get saved to slots that were previously empty. So that's a big time saver too, because if you allow your clients to define snapshots for their own presentation, and you allow them to save it to disk so that they can retain those snapshot values based on their own preferences. If they were to overwrite a snapshot, so that say if they, for example, they wanted this to be nothing, they can save over top of it, and that name won't change. It'll stay as the name that existed before, as long as there was a previously existing snapshot in that slot with a predefined name. So you can see here, since we saved a completely cleared state of all three devices, and if we recall it on the 2x2 matrix, so let's just root something, you can see. So source A1 is there now. If we recall, you can see their snapshot got recalled there. We can actually do it on the 3x3 as well. So if we did that, saved it there, cleared it, and recalled. So it essentially roots the no source value, because that's part of our dynamic text thing that got routed through all the three matrices, but it routed it to F1. That's a bad example because no source is going to exist whether that routing is enabled on this switch or not. And some of the other things, because there's a lot of things involved in these modules, is all the partial snapshots and input video detect and sync and all that. It's really hard to put everything on a single panel. It's starting to look like a control center almost, but I tried to explain just some of the more complicated and less intuitive parts of the functionality that this module provides, in hopes that this will help many people understand how to use these modules effectively, because these modules, I guarantee I haven't really seen much functionality like this out in the real world, and this will allow you to provide your clients with some pretty advanced matrix switching logic in a fraction of the time that it would take other people to do this, unless they've already built modules like this.